Welcome to AppViewX Network Automation Demo, where I'll demonstrate how to leverage the AppViewX visual workflow to publish a self-service request, enable cross-team collaboration, and ensure fast yet accurate service delivery. Let's start by logging in as a workflow design engineer or administrator, then navigate to the Studio Workflow module. With my permissions, I'll see the automation workflow designs, but I'm going to select to create a new one and give it a name. I'll then select the integration set from the library on the left, followed by Ansible, and then a folder of choice containing playbooks. I'll then drag and drop the playbook of choice. In this example, I'm using a Create F5 virtual playbook. Here's the YAML content of the playbook. Note that I have defined a number of variables that will be used in the playbook execution. After saving the playbook, I'll then go back to the original Ansible library and pull the Ansible executor onto the design palette, and then save it. Now it's time to construct a collection form so that the variable definition list can be created and passed into the automation sequence. I'll go to the user interface section of the library and pull the form object onto my design palette. From there, I'll name the form and then use the form builder to design how the form input will be gathered. I'm bringing up a caption window of the YAML file because it contains the attributes that will be used in each execution of this workflow design. Note, in the Field Properties window, I'm presented with attributes to be assigned to each variable. Select attributes are used depending upon how you want the form to appear and what constraints you would like to be placed upon each field. For example, I specify a text box field type for the username, but alternatively, I can select a password field type for the password. The label name is what an end user will see when completing the form, and the field ID is the key ID reference, which we will refer to in a moment when we associate these field properties to the YAML content file. Also note, I can apply helpful descriptions to a field, which might assist an end user in completing the form. I can also validate input parameters to ensure they match desired regex filters. For example, validating that an IP address has been entered. Additionally, I can generate predefined field values to be presented as a drop-down list. I've elected to do just that in the case of collecting variables such as pool member port 80 or 443 and health monitor types HTTP or HTTPS. Once the form has been built, I can preview it. I can even decide that I would like to dress it up a bit by grouping segments of form data. In this case, I want to visually segment data associated to the F5 device, VIP parameters, and pool parameters. In that case, I select the fields referring to each group and select the Assign to Group option near the top. Name and then add the group. I'll repeat this for the remaining group definitions. Once I've finished, I can again preview the form. There, that's better. Now that the form used to collect variables needed for executing my automation workflow are complete, I'll need to associate the field IDs to the YAML playbook. I'll do so by opening the YAML JSON editor. Place my cursor at the end of the item in my vars list and then select Ctrl+G buttons, which will show a list of the global variables contained in the form I just built. I'll associate each of the form fields with their related var definition and save the YAML editor file. Now that I've defined the association between the form and the YAML editor, I'll need to make one more association between the YAML editor content and the Ansible executor. I'll go back into the YAML editor and open the global variables item where I can store multiple lists, but by default, I have only one, which is called editor content. So I'll copy the list reference value, save or cancel the editor, and then open the Ansible executor. I'll then paste the copied value onto the value content bar and click Save. I'll simply connect the sequence tasks in the order I need, which is from left to right in this case. I'll preview the workflow to make sure it looks good, and then return to the design palette. Now I can begin to publish the new automation workflow for other roles and technology Skillset contributors. I'll select the settings gear icon where I can share access to the workflow design. I'm going to make this available to the DevOps org unit and click Save. Going back to the automation workflow inventory list, I can see my newly created workflow. I'll want to associate the RBAC permissions for the workflow by selecting the settings gear icon and the RBAC tab. I can control whether or not the org unit can access the YAML playbook, which was named Create F5 Virtual, or just submit the input vars form. Once I save the settings, my workflow will be successfully enabled. The final step will be to enable the workflow. I'm now going to log in as a member of the DevOps org unit. I'll navigate to Self-Service Requests Inventory, and I'll find the published automation workflow. I'll run the workflow and fill in the variables. I'll then submit the request. Because I granted access to review the Create F5 Virtual Playbook, it will be presented, and I'll select Next. This will begin the execution of the playbook. And in just a few moments, the implementation will be complete. I'm jumping over to the F5 Big IP web user interface to refresh the virtual service list, and voila, you'll discover the newly created virtual service instance. I hope you found this brief demonstration to be informative, and I thank you for watching.